Well, hello everyone. Before we dive in to the science of quantum mechanics with someone far more qualified to explain the equations and experiments and all that stuff, I'd like to offer a different kind of introduction, one that looks at the world behind the science. So Dr. Garland has given me this assignment. So here we go. So quantum mechanics didn't appear out of nowhere. It was born during a time of great change when artists, philosophers, political thinkers, and scientists were all starting to question how the world works and whether the ways we've always understood things could still hold up. Today I want to tell you a little bit about that world so we can have a little bit of historical context as Dr. Garland comes and talks to us. And I want to invite you to approach this topic not just with your intellect, but with your sense of wonder. Because quantum mechanics isn't just about particles and math. It's about reality itself and what it means to be human in a world that is far more mysterious than we could ever have imagined. So let's go back to the early 1900s. Cities are growing really fast. Electricity is lighting up the streets. Cars and airplanes are still brand new. The telephone is starting to change things a little bit, and it's going to change communication forever eventually. And in most countries, women still do not have the right to vote. So now, at the same time, during all these things that are happening around the year 1900, at the same time, most scientists believe they've figured out the basics of how the entire universe works. Up to this point in scientific history, they really thought they had stuff figured out. They think at this point that the world is a giant machine, very predictable, logical, and fully knowable. Pretty sure they've got it figured out. If you know where something is and how fast it's going, you can figure out where it will be tomorrow, next week, or 100 years from now. But cracks are beginning to show in this worldview. Because in every corner of culture, the world was cracking open. Artists abandoned strict realism, exploring emotion, abstraction, fragmentation. Music broke free from traditional harmony. Composers like Stravinsky introduced dissonance and rhythm that shocked audiences. In literature, time became fluid and narrators became unreliable, as if even the human experience could no longer be pinned down. So, politically, revolutions were brewing and had brewed, empires were strained, and the old world order no longer felt secure. And in science, for our purposes tonight, quiet observations in really dark laboratories began to whisper something pretty wild, that beneath the surface of things, reality itself might not follow the rules, or what they thought were the rules. And in the midst of all this uncertainty, a handful of thinkers began asking radical questions about the nature of reality itself. So let's take a look at some of those thinkers. So the first thinker is Max Planck. And Planck was a German physicist who did not intend to start any kind of revolution. He was simply trying to explain how heated objects give off light. But in doing so, he introduced the idea that energy is made up of tiny packets called quanta. Get that? Quanta? Quantum physics. Though Planck didn't foresee its impact, his work quietly opened the door for a whole new understanding of nature. He lived through the rise and fall of empires, world wars, and the moral crises of Nazism, holding on to science as a steady pursuit amid great political and personal upheaval. Next, of course, we have the very famous Albert Einstein, perhaps the most famous scientist of all time in all of history. Einstein supported Planck's ideas early on by suggesting that light itself could behave like a particle. This work won him the Nobel Prize, but he remained very skeptical of where quantum physics was going. He disliked its randomness and complete uncertainty, famously saying, "God does not play dice with the universe." And so as a Jewish intellectual, Einstein fled Nazi Germany and spent the rest of his life in the United States, advocating for peace and justice and doing some amazing scientific work. Niels Bohr, also a pretty famous name, was a Danish physicist and took quantum theory a whole step further. He argued that reality might not be something we simply observe. It might actually depend on how we observe it. So pay close attention to this because Dr. Kat's going to come back to this. During World War II, Bohr fled Nazi-occupied Denmark and later worked to ensure science would be used for peace and not destruction. He believed deeply in paradox and dialogue, once saying the opposite of a profound truth may be another profound truth. And that sounds pretty Unitarian Universalist if you ask me. Werner Heisenberg was a brilliant German scientist, and he introduced something called the uncertainty principle. The uncertainty principle revealed that there are fundamental limits to what we can know about the tiniest parts of nature. He worked under the shadow of the Nazi regime in World War II, making choices that historians still debate, actually. Like his theory, his life was marked by complexity, ambiguity, and deep questions about ethics and responsibility. And then the final person I want to highlight is probably my favorite of the bunch. So Marie Curie, working slightly earlier than these other figures I've mentioned, wasn't a quantum physicist herself, but her work on radioactivity laid the foundation for atomic science. She discovered that atoms weren't solid and unchanging. They could break apart and release energy. This is a big deal, of course, if you know your science history. Curie was the first woman to win the Nobel Prize and the only person to win in 2 different scientific fields. Her courage and dedication broke barriers and inspired generations. Together, these scientists show us that quantum physics wasn't born in isolation. It was shaped by war, migration, revolution, and the deep human need to understand a world in crisis. Their discoveries reflect the uncertainty, contradiction, and beauty of their time, and perhaps ours as well, actually. So in just a moment, we're going to hand things over to Kat, who will walk us through the actual science of quantum mechanics, what it is, how it works, and what scientists today are still trying to understand. Remember, this is not just a story about electrons and equations. It's a story about people who dared to look more closely. People who weren't satisfied with easy answers. People who believed that even the smallest parts of the universe had great meaning. So let's enter this conversation as people of faith, of the Unitarian Universalist faith, people of learning, and people of awe. Let's remember that the more we learn about the universe, the more mysterious and miraculous it becomes. And let's celebrate the fact that in asking these questions, we are participating in something I think can be described as sacred, which is the never-ending human search for truth. I'll see you in just a second.